So today we're doing a thing called completing the square. And that's how you get from general form to vertex. But I think it'd be best if we just did a few practice problems. So here is something that is in factored form. Hold on, it's stopped me from writing. That's the first time that has ever happened. My iPad said optimizing. I've never seen that one before. All right, that's factored form. Would you agree? If I asked you for general form, what would you do? Generally, you just multiply it out. So go ahead and do that. So what's factored form good for? It's good for finding the x-intercepts. Like I can tell you just right off the bat, it's 4 and -3. Those are the x-intercepts because it's in that right form for that. All right, would you please compare the answer with this kid sitting next to you? Even color coded. Final answer all in black. X squared minus x minus 12. Raise your hand if you had that one right. Cool. Did any of you have this instinct like, oh, I should probably factor it? I mean, I do, because if you can factor it, you should. But yeah, it's already factored right here. So those are the two big ones other than vertex form. And if I said, all right, I want vertex form, right now you'd have to go this really kind of clunky way. First, you'd have to figure out the x of the vertex, which is the axis of symmetry. Then you could figure out what the y part was. All right, so let's actually do that. Would you figure out x equals -b? What's that little formula again? Over 2, what? A. Do that, and that'll tell you the axis of symmetry. This way will work to eventually get the vertex, and then you can finally make vertex form. So our A, B, and C, I hope they're obvious to you. They're 1, -1, and -12. Those are your three big numbers, A, B, and C. So -b would be negative of -1, so it would be 1, over 2a, which is 2 times 1, which is 2. So it's 1/2. Do you get from here, it's going to be a bit of a pain in the butt because now we know the axis of symmetry, but that just gives you the x of the vertex, and now you'd have to stick the 1/2 back in the equation to get the y, and it'd be a pain, right? Okay. You could find the vertex that way. My job is to show you how to find the vertex another way. Or if I give you an equation like this, y equals x squared plus 6x plus 9. If you want vertex form, you can do it just like bam if you know this method. Instead of having to go find the vertex with -b over 2a, I mean, it takes a long time, you can just say, boom, I have the vertex. All right. And it has to do with this. You look at this number here, and you ask yourself what half square is. Probably never heard that series of words before in your life, half square. Well, I'm going to take half of it and square that. What's half of 6? Square it. 9. And, well, that's this number. In this case, I set it up on purpose to work out perfectly. So then, if you were to write this in vertex form, I bet somebody smart can figure out what would be in there. Say it if you know it. Plus 9, no, because then 9 times 9 would be 81. 3, there it is. Now, why is this better? Well, it's just x plus 3 and x plus 3. Isn't that just factored form, Mr. Server? Well, kind of. It is factored form, except if I put a plus 0 here, do you get how I could then say it's kind of like vertex form? So what's the vertex? Yes. -3, 0. Good. And now that I know the vertex, I could make vertex form, but I already have vertex form. You don't have to go make vertex form. You already have it. All right. So I know that most of you are still like wondering what exactly is going on here, but try this one. X squared minus 2x plus 1. Is this that kind where you could make it into something squared like this? Because if so, then it'd be in vertex form just right off the bat. Is it like x minus 2 squared? Well, it's not x minus 2 squared. What do you think? Well, if you're not that good at doing it that way, how about if you just factor it? Can you factor it? X and x. Would you agree they both have to be minuses? Minus and minus, and then don't they have to be ones because they have to multiply to 1? 1 and 1, and then can you do it now? Raise your hand if you already had x minus 1 squared. Okay, cool. Now, why is this good? Because it's vertex form. If I just put a plus 0 here, I'll be able to see the vertex really obvious, 1 comma 0. Now, you might say, but that only works occasionally when this number happens to be half of this and then squared. And yeah, I've been cheating. I've been making it work every time. So I'm going to show you what to do when it doesn't work. Yes?
Why is the y for the vertex 0? Shouldn't it be c?
Okay. How about this? Would you agree that if I multiplied this all out and I got the c term, that's the y-intercept? You're thinking of y-intercept. That's not what we want. We don't want the y-intercept. We want this number, and there is no number there, and so I'm just putting a plus 0. Isn't it legal for me to put a plus 0 at the end? I mean, that doesn't really do anything, right? So the vertex really is 1 comma 0. And the c you're talking about, that's actually the y-intercept. That's different. All right, so let me give you one more, and this one's on purpose not going to work. X squared plus 4x plus 5. And you might think, oh, I can factor that. No, you can't. It's not going to work. Know how I know? Because if I do half of that and I square it, I don't get 5. What is half of 4? 2 squared? 4. If that would have been a 4, it would have worked neato. Okay, so since that's not a 4, here's what you do. Everybody follow this one exactly, like write everything I write and listen at the same time. So everybody, if you haven't already copied the original problem, copy the original problem. Now I'm just going to rewrite the original problem, except give it some space. All I did is put the 5 over a bit. I need some space to work. See, I just moved it over so that I have some space here. In that space, I am going to make this part factor perfectly. I'm going to just cheat and say, I wish that there was a 4 here. How would I know? Because I go half of that, half of 4 is 2, and then I square it is 4. Do you get then it'll do that neat little trick? Do you get that this one works? It'll turn into x plus 2 squared, see? But wait, you can't just go stick in any number you want to, unless you add 4 to both sides. But wait, don't actually add 4 here. It'll just get messy and you'd have to get rid of it by subtracting 4. So I'd just be fine with you immediately putting a minus 4 there. Would you agree that when I put in plus 4, I needed to put in minus 4 to counteract it? You know, keep it balanced. Either that or if I add 4 to one side, I have to add 4 over here. But instead of that, I'm going to just right away subtract 4. Okay, so let me finish it. Y equals, and if you aren't good at these yet, you'll start getting good at them in your head. That's x plus 2 quantity squared. If you don't get that, it's because it came from this. X plus 2 and x plus 2. That's what it really factors to. And then what about this part? That tells you the other part of the vertex. What's negative 4 plus 5? Plus 1. Do you get that now? This right here is the same equation but in vertex form. So now I can tell you the vertex really easy. It's negative 2 comma 1. And if you ask me for the axis of symmetry, I'd be right in my wheelhouse. X equals negative 2. Boom. Easy. Done. All right. Now, my official lesson plan has me just stopping there. And I'm like, oh my gosh, this is an honors class and you can go further than that. So we'll practice this one more time. But then what I'm going to do is teach you tomorrow's lesson ahead of time, because it's like just taking this one more step further. So this would be too easy. Like seriously, it's 6 minutes into class and I'm already like, I could be just done and say, go do your worksheet. And that's ridiculous. And I know some of you are like, yeah, I want that. But if we do that, then tomorrow's going to be a hard day. If we get it over with now, tomorrow will be a nice, easy day. So I'd rather have tomorrow, Friday, be the nice, easy day. Okay. All right. So let's get one more up on the board here. Y equals x squared minus 10x minus 2. And you could try to factor that all day, but it won't factor. So then you need a little space. So the first thing you do is just move that 2 over. And I'm fine. You guys have an iPad. You can just erase the minus 2 and move over a little bit. Okay? And then in here, you want the perfect factoring thing. You figure out, don't say it, there's a number that goes right there, and then you put the opposite of that number right there so that it cancels, and then see if you can do it. The research shows that it's better if I let you struggle a little bit when you maybe can do it than to just spoon feed you this one. Give it a shot. See if you can complete this one. Probably only have half of you, but give it a shot. I'll pause while you give this a try. All right. Half n squared. Half of negative 10x is negative, well, it's just a number actually. So negative 5, and then you square it. Because if it's negative, it won't even matter, because when you square it, it won't be negative anymore. Hear me now. This will always be plus right here. Like this will always be plus, because you're squaring whatever half of this was. And when you square it, can't be negative anymore, you know? Okay, so then it's 25. Raise your hand if you knew that and you had a 25 there. Awesome. Did you have a negative 25 here? Awesome. Then can you factor? Because if you can factor it, you should. Doesn't it come up like seriously every day? That's why I had to get you good at factoring early in the year. That's why we kept doing that first 20 over and over again. And some of you still are resistant to that. And if you can just get that down, days like today are like, well, that's easy. X minus 5 quantity squared. Boom. Okay, and then what's that? Negative 27. And then do you get, I've just changed it from what it was. Let me go back to the original. The original was this. Would you agree the original was in general form? And now I just changed it into vertex form. And that was the goal for today. To take it from general to vertex. And this will work. There are ones that are harder, though. I've on purpose been picking easy ones. Like, you know, when you're teaching a kid how to hit a baseball, you don't like throw fastballs to try to make him miss. You throw up nice, easy ones so they can hit it. In fact, they even play a game called T-ball, where the ball is sitting still on a tee, and then they can hit it, right? So I've been giving you easy ones. Let me give you a harder one that's not so easy. Y equals x squared minus 7x plus 1. Well, the first step is exactly the same. You need space. So put the plus 1 over here. And now it just needs you to be good at fractions. Sound like one of those basics? You learned them in 4th grade. Should you be good at them by now? Yes. Were some of you good at them at the beginning of the year? Yes. Are some of you bad at them? Oh, yeah. And some of you are still bad at them. And you're going to be like, oh, crap, fractions. You are older than you were the first time you learned this. You can handle this. Half and squared is what we got to do to get this number. But it's a fraction. I can't. No, it's fine. It's just 7 over 2 is half of it. Right? 7 over 2 is half of 7, isn't it? Wouldn't that be 3.5, which is half of 7? I know some of you want to use a decimal. Warning you, it's so much easier to use fractions here than decimals. Like, I like 3.5 better. Fine. When you square it, are you going to like that? Because 3.5 squared isn't so nice, is it? So, when you do this, which I said would always be positive. Why? Because we squared this. I'm just going to square it by putting a squared at the top. Can you do 7 squared and 2 squared in your head? No, I can. It's not that bad. That's 49 over 4. But I personally would just leave it like that. Would you agree that I just put in half of it squared? Right? Isn't that what I did? Half and squared. That's what we did before. It just happens to have a fraction. Now, out here, I have to do it again, but I'm just being smart here. Instead of putting 7 over 2 squared, I'm going to actually square it and put that here. Remember, it's always the opposite of it because we're trying to counteract it. 49 over 4. Do you get what happened there? These are always opposites. If this one's positive, which it always will be, this is negative, which it always will be because the other one's always positive. And they're trying to counteract each other. Now, you actually have to have some skills with fractions because you're going to have to add these. So if you don't know how to add things with common denominators, that's another one of those first 20 that I've been asking you to learn. You got to know how to do common denominators. And some of you that have that are like, yeah, that's easy, Mr. Server. You just put this over 1, you times it by 4, you times it by 4. It's no big deal. And those of you that don't know your basics, this is another moment where it rocks your boat. Would have been good to learn that when I told you to. We started with it on day 2 of this class, about 2 months ago. You could have learned it by now. Okay, so now I'm going to go x minus, and now this one does bear watching. Watch this. This number here is super easy. It's 7 over 2. I know that's not necessarily intuitive, but if you look back at the last time we did this, do you get that it was the square root of 70, or square root of 25 came down here as the 5, because 5 times 5 makes 25. And on the previous one before that, we had a 4 here. And look, we ended up with a 2 here. The square root of it. So that's why it was smart to leave 7 over 2 here. Because 7 over 2 squared, the square root of it is 7 over 2. So that just goes right there. And now the only thing left is to do some fraction work. I'm going to rewrite it like this. Negative 49 over 4 plus 4 over 4. And if you can't do it from that, you probably should get your basics fixed. Because if you're going to survive in honors, you have to be able to do stuff like that. Negative 45 fourths. Raise your hand if you had it before I did. Okay, cool. Is that actually a scary looking equation? Yeah, it is. It's scary looking, and you just did it. And it wasn't that bad. Was it? You had to do half of something. And then you had to find a common denominator. All right. So let's do one more like that, except you be completely in charge of this. Y equals x squared minus 3x plus 1. And I'm just going to save some time and move it way over right off the bat. Would you please start with this general form equation and do that, complete the square it's called, because you're making a perfect square. And you use half and square to do it. Pause for a sec, let me give this a shot. See, if you were taking regular higher algebra right now, you wouldn't have to do this. You would have been done earlier. This fraction stuff, this is stuff that an honors kid is supposed to be able to handle. All right, dice of destiny. Who should I call upon to walk me through this? Don't worry, if you can't do it, I'll help you. But I don't let kids just say, I don't know, so they can get out of it. Otherwise, everybody will just say, I don't know. So if you don't know, I walk you through it. Row 4, person 2. 1, 2, 3, 4. Person 2, Amelia. So tell me, this half and square thing comes in handy. What do I do again? and then half and what? Squared. Very good. Now, you could write that identical thing right here, except remember, once we square this thing, would you agree it's going to come out positive? So then this one has to be negative to counteract that. And then, can you just square it for me? We can put that there. 9 over 4. Excellent. But I'm going to have to add fractions. Scary. I hope you can just get this done. X minus 3 over 2, quantity squared. That just comes straight down here because it's the square root of all that. And if I make this 4 over 4, you'd agree that's the same as 1, as 4 over 4 is 1. And now they have a common denominator. Now it's minus 5/4. Raise your hand if you had that one right. Cool. It's not that bad. You know fractions. Yes?
I'm pretty sure when we were doing this earlier, we were using the divided by 2, just take that, but
No.
we're doing the signs.
Let's look back. You said you think we're doing divide by 2. When I went from 25 to 5, was I dividing by 2? No. I was taking the square root of it, wasn't I?
Yeah, but then you were squaring it. You're dividing by 2 and then squaring it. Like, just my question is like.
When this is a 4, I see why you might have thought it was divided by 2, but it was the square root of 4 was 2. Okay, so if you're saying, why aren't we dividing by 2 about this part, the reason we're not dividing by 2 is because we never did. We did the square root of this thing right here, and we put it there. Is that what you're talking about?
No.
Okay. Tell me about the divide by 2 you're talking about.
Well.
I don't remember ever dividing by 2.
I think like the signs are wrong, positive and negative, because before we were.
Okay.
Just copying it out for like.
All right. So, you think the signs are wrong, and I feel like that's a good thing to check. So let's find out. See how there's a negative right here? If I made this positive, then it would really mean x plus 3 over 2 times another x plus 3 over 2. And how could I end up with a negative number there? That can't be positive. It has to be negative. So the sign is correct in there. And then about the sign on the outside? And the sign on the outside, which one's bigger, 4 over 4 or 9 over 4? 9 over 4 is bigger. I think you know that. And therefore, that one wins in its negative. So our signs are actually right. But it's okay to ask. I'm glad you asked. All right. This is the part where we're going to go through some notes, and I hope they're going to seem relatively easy for you. So this is the general form, and that's how you do it with letters, A, B, and C. And just so you know, I think you need to stand up and walk back to the pencil sharpener and sharpen your pencil.
Sure.
That's all right. I know. Now you'll probably be fine. Okay, so this has got an H and a K, whereas the other one has A, B, and C. All right, just leave him alone. I was talking to him, not you guys. All right, so go to this page, and this one, did I do half n squared on these? No. These are not those perfect squared things, are they? Because a half of 12 would have been 6, and then, oh, wait a minute. Oh, that is a perfect square, isn't it? So do you get how this one should be super easy for you now? X, it's got to be plus because there's only pluses in it. And then you use the square root of this. X plus 6 squared. That makes sense? And this one, is this the half and squared thing, like right off the bat? It is. So it should be super easy. Everybody do it quick. I'm going to call in somebody with the dice of destiny. Row 6, first person, Carter. Can you do this?
The second one,
Yep, right there. Right in here.
it'll be the square root of 49.
Okay, so x and then what? I know the square root of 49 is 7, so what do I put? It looks kind of like this.
-7.
Yes, there's a minus because of this. Very good. And you want to finish it? X minus 7. Hint. Look at the last one.
Squared.
Squared. Otherwise, it wouldn't be in vertex form. X minus 7, quantity squared. All right, moving on. This is just asking, what would you want for each of these? It's basically making you practice the half n squared thing. Fiona, that first one, half and then square it. Yep. Keenan, next one, half of it squared.
9.
Yep. That's fine. Next person, row 3, person 2, Liam.
4.
Yep. Brooke.
B over 2 squared.
Ooh, you did b over 2 for half of it and then squared. Perfect. A lot of people would have locked up. Way to rise to the occasion. And row 2, person 6, Reed, that's you.
3 over 2 squared.
Not 3 over 2. I know you were thinking half of 7 is like 3.5, but try again.
7 over 2 squared.
There you go. That's it. All right. On to this next one. Now, can you complete the square? This is the part where they'd normally teach it to you, but I already have, so I'm thinking you can do this. Ethan, I'm going to stretch it out first and move the 20 over. Can you tell me the half and squared thing I should do?
Plus 16.
Half of 8 is 4. 4 squared is 16. Very nice. Then this part factors. It'd be really easy to forget a really important part here. Amelia again. Dice like you today.
Wait, what?
I forgot something. What I wrote is not right. Because I forgot something.
Oh, you're doing minus 16.
There you go. Correct. Then, to simplify it to the final answer. Brady.
So would it be y equals x minus 4 squared?
No minus, because look, the problem only has pluses.
Oh,
Plus 4 squared. Keep going.
plus 4.
Yes. Yes, yes, yes. I delayed so long you thought you were wrong. Nope, you were correct. Plus 4. There you go. Who had that one right? Good. Moving on. So, it's telling you just all the steps here. And I feel like it's just going to be actually more confusing than if I just say, look at the beginning, then by the end, and do you get that they have it in vertex form at the end? Now, I think the way I showed you is a lot easier than all of that. So I'm not going to confuse you with that. We're just going to go on to this one. And we're starting with general form. I'm moving the plus 50 way over to give me some space. I want people to talk me through this. You guys all do it, but I'm going to call on you for different steps. Vaughn, what do I do this for this part?
You would cut negative 14 in half. And then
Which is
square it.
-7 and then?
Plus 49.
All right. Half n squared. Perfect. Next part. Kate.
You have to add the -49 outside of the parentheses.
Excellent. Remember why we're doing that is because we just added 49 to this perfectly innocent equation. You can't just do that. You have to counteract that to keep it equal to the original. We could have added 49 here instead, but you just have to subtract it to get it back to y, so that's why it's there. Okay. next part. Row 5, person 2, Madison, that's you. Final answer, I think.
X plus 7 squared.
So close. Look back on it, try to find your mistake. It's really, really small. Do you see that the original problem has a negative in it? That means this has to have a negative or you can't ever get a negative in your answer. They'll all be positives. There it is. All right. I think we've done enough except for actually starting the homework. So everybody start the homework. I'm going to give you a sneak preview of tomorrow's. As I realized the fraction thing threw people a little more than I was hoping it would. So I'm not going to fully teach you tomorrow's lesson, but I do think it's good for you to realize what we never did was this. What's different about that one than all the ones we did? Something different about it, yes. Yes, that changes the problem so that we can't just do half and square and all the stuff we just did. So I'm going to show you, and some of the best and the brightest of you are going to have only this one example, and I bet you'll be able to do it tomorrow because you're that quick at picking up math. Just think of this as a challenge. Can you handle this? The only difference is in the fact that there's a 2 here, so you get it out of there by factoring. And I know some of you are like, but this doesn't have a 2 in that. You're right, but you can still factor out that 2 from just the first 2 terms. And you move the 5 way over here. You can do that? Yes, you can. Think about it. If I multiply this out, I will have exactly what I had in the first place. You can factor something out of just the first 2 terms. And then you do your half and square. Because if you can factor it, you should. Once again, for the 37th time, factoring saves the day. So that gets factored. And then I do half and square. Half of 2 is 1. 1 squared is 1. If I do a plus 1 here, I got to do minus 1 there. But wait. Wouldn't this 1 get multiplied by a 2 if I multiplied all that out? So this has to be multiplied by 2 also. Final answer, y equals 2x plus 1 squared. You might be like, square root of 1 though. What is the square root of 1? It's 1. And then negative 1 times 2. Why did you do that? Because this was going to get timesed by 2 right here. So this has to be timesed by 2 also to make sure that it really counteracts it. And then last but not least, the negative 2 plus the 5 makes 3, and there's your final answer. Now, some of you, that'll be enough. You'll remember to just factor it, and you'll remember this little oops, gotta remember to multiply that other number by 2, and you'll have tomorrow's down before I even start it tomorrow. Some of you haven't got it, and that's okay. I get it. I just gave you one example of a really hard problem that you've never seen before today. Question. How did I get the 3? Negative 2, positive 5. Yep. Why did I multiply this by 2? Because this one was going to be timesing by 2. That's okay. Yeah, I understand. From the position I wrote it in, it would totally make sense. All right. That was just a preview of tomorrow. Now, let's actually start tonight's homework. Catherine, in a moment, I'm going to ask you to read me problem 2, because I'm sensing you don't have problem 1 up because you're smiling at your screen too much. Nobody smiles at their math assignment. Okay, Mr. Keenan, could you read me number 1 of the assignment?
X squared plus 16x plus 64 plus 7.
Was I wrong, Catherine? You actually had your math assignment up?
Yes, I'm already done.
Okay, fantastic. All right. I'll still call on you for number 2, but you were smiling too much. Just kind of threw me off. I'm thrilled that you like math that much. All right, so is this one of those ones where it's already preset up to just factor boom right away into this? Well, you check and see, is this half and squared? Yeah, it is. So then you should have the answer right off the bat. Read, final answer.
Y equals X minus 8 squared.
You threw in a negative that didn't exist. The problem only had positives. That means you only use positives. And then for the people that are like, but I thought there's supposed to be a number here, put a plus 0 and you'll feel better. You don't have to, but you could. And then you'll see, oh yeah, the vertex must be -8, 0. All right, Catherine, as promised, read me number 2.
X squared minus 12x plus 36.
Is this one of those kind that's already been half and squared? Yeah, it is. So then you can just go right to it. Boom, boom, something squared.
First section there.
Do you know what the answer is, Catherine, by chance?
Yep.
What is it?
Y equals x minus 6 squared.
Correct. If you're feeling extra, put a plus 0 at the end. You don't have to. All right, I need to see this so I can see which problems I might want to have people skip. Thank you.
It's really long, or.
Fair concern. All right, so let's scroll back down. I think problem 2 is just kind of dumb. So cross off problem 2. All they're doing is half and squared part. That's too easy.
The entirety of.
Yes, problem 2 had A, B, C, D. Just skip that. Okay. Problem 3, complete the square to write each of them in vertex form and then graph it. Oh, it's not that bad. You're just doing vertex form and then you're just graphing it. If you remember, once you have the vertex, pretty easy to graph problems. But let's actually do number 3. Would you read me 3A?
Y equals x squared minus 6x plus 5.
And I'm going to move the plus 5 way over because I know that's not half and squared. Brady, what is the half and squared number?
Would it be 9?
Yes, it is. I'm being extra by saying positive 9. And then we'll put a negative 9 here to counteract it. Keenan, put it all into vertex form, which is much easier to graph.
Y equals x minus 3 squared.
Yup. But then you got to tell me that part too.
Minus 4.
All right, and if I had to graph that, I would go to -3, -4. Oop, I'd be wrong. Not -3. +3. Opposite of what you would think, right? And then down 4. And there'd be a dot right there. And then I know it's a parabola, so I know... Have you memorized this pattern yet, that you always go over one and up one from the base? Know what I'm talking about? Then don't think it's a V shape. It's a U shape. You go over 2 and up 4... because you're, squaring. Fundamentally, this is y equals x squared. It's just been moved a little. So those are your first points. And there we go. If you get these 3 correct and you don't think it's a V shape, because some kids are like, no, that's an absolute value. It's got to be more like the blue one. Then you got it. It's not this. It's got to have distinct points. The hardest ones are just these over 2 and up 4. And that's not that hard if you remember it's just squared. Okay. And of course, you can always go back to the XY chart and it would be slow, but work. You could stick in 3 and you go, oh, I guess I get -4. And that's the vertex, which we started with. And then you could stick in 4 and you could stick in 2 and eventually you get enough points. That's the slow way to graph though. Might as well just go right to the vertex, follow the pattern. All right. Now, I agree that this assignment is a little long, though, to try to keep your life reasonable. Let's go to, we're going to skip D, E, D and E.
We don't have to do that?
Skip D and E, correct. You could not to do those. Skip donkeys and elephants. And I think even the rest, I'm giving you a ton of time left at the end here, so you should be able to maybe even finish this thing if you really understand this. So, nice, easy day. All right, that's all I got for you for today.